Let's get started with our first algorithm, Needleman-Wunsch algorithm for global sequence alignment. Given that we have two different DNA sequences, the first sequence is GAC and the second sequence is ACG. How can we identify the most optimal alignment between these two sequences? The first thing we have to do is to create scoring matrix. Shown here is our scoring matrix. Scoring matrix is the table, and we have to put the score in each cell of the table. One thing to remember when making scoring matrix is that we will skip the first row and the first column and leaving this cell as the blank cell. We will start putting the first nucleotide of the first sequence on the second row and the first nucleotide of the second sequence in the second column. Let's move on to our next step. So to fill the score in this scoring matrix, we have to understand three basic steps. 3 steps for putting the score in. The first step called initialization. The second step called matrix filling. And the last step called trace back. This is the 3 main steps that we will be working on. Okay, let's move on to the scoring function. For scoring function, it is the function that determines which score we will give to each cell. Normally, the score of function we will denote it as the f at I and j, which means that the score at I row and j column. If we have f at 0 and 0, it means that I equal to 0, j equal to 0. This means that the score of the first row and the first column here. In this 0 index, the 0 number is the first row or the first column. Okay, so now from this scoring function here, you can see that for Needleman-Wunsch algorithm, the first row and the first column, we have to put the 0 score. So I will replace this one here with 0 score. So by default, we have to put the 0 here at this cell. And we will go on to the scoring function here. The scoring function here, we have two score, 1 and -1. We put the score 1 if the nucleotide sequence from the first sequence is similar or identical to the nucleotide at second sequence. In other words, it means that if nucleotide match, we will put the score 1. And we have otherwise cases. If mismatch, we will put the score -1. And if we have gap, we will put the score -1 as well. So we will work on the initialization step, the first step. I would like you to look at these two lines. You can see that we have to perform addition with D. D means the gap value. So we will put the score for the first row and the first column by using gap value. So for the first row first, I put the arrow. Every time you put the score in, you have to put the arrow to indicate the direction of the score. So 0 plus gap penalty score -1 will be -1. -1 plus gap score -1 will be -2. -2 plus -1 -3. We will put the final score in the first row. We will do the same in the first column. 0 -1 -1. Don't forget to put the arrow. -1 -1 -2. -2 -1 -3. So we end the first initialization step.